All right, I think we can go ahead and jump into it. As mentioned, my name is Amelia. I'm an architect. At Finch, I work primarily with our enterprise firms, both before we partner with them, but also quite a bit after. I also have here today with me Reuben.
Hello, everyone. My name is Reuben. I'm, like Amelia, also an architect. I'm so excited that we have so many of you with us here today, and really excited to jump in and demo what Finch can do.
Perfect. So the structure of today's webinar is going to be, we'll have a few introduction slides, and then we'll go through a live demo. At the end, we'll also show some new features, such as generating plans in Revit, as well as working with master planning. So we'll go through those. And then, of course, we always have some time for Q&A at the end. This session is recorded, and you guys will all receive a recording of it in the coming days. As we go, if you have any questions, just write them in the Q&A, and we'll take them at the end. So I'll go ahead and share my screen, and we'll jump into it. All right, so just a bit of background about Finch itself. Finch is a generative copilot. It's designed by architects. Both Reuben and I are architects. The founders are also architects. And this is kind of who we envision using Finch and kind of what the features are designed for. It is a design tool, so it definitely needs to be steered by an architect. The idea is that it automates a lot of these manual processes and ultimately saves you a lot of time. Here's also a quick introduction into us here at Finch. So Pamela Nunez Valgren and Jesper Valgren, they are both the co-founders of Finch. And then I myself work as an account executive, and Arthur Edman, he is not here today, but he also works as an account executive. So if any of you guys want to get in touch about Finch Enterprise, feel free to reach out directly to us. Currently, we have around 100,000 on our waiting list, people that are waiting for access to Finch Enterprise, which is very exciting. But also, we can't open up to everyone at once. So what we have right now are two tiers. We have the Finch Basic tier. This is open to everyone. All of you guys can access that already today. We also have the Finch Enterprise tier. This is available to select firms. And with these enterprise firms, we build a custom data set in their style, so they're able to sort of generate plans that are compliant for their local regulations. And today we will be going through the demo. And as we do that, we will highlight kind of what's included in Finch Basic when we are transitioning to Finch Enterprise, where Finch Basic stops and when Enterprise starts to play a role there. So stay tuned for that. These two tiers are very different in terms of their features included in them, as well as the support included in them. So the Finch Basic tier, this is for single users. This is priced at 49 euros per month. And this is available already today. You guys can go sign up. There is a 14-day free trial included in that, so you can take a look around there. If you're interested in Finch Enterprise for your firm, this is priced at 1,000 euros a month with multiple licenses. It's kind of like a package. It includes training, onboarding, and then most importantly, it includes the data set build, which allows you to sort of generate plans in your local style. So just a bit about Finch Enterprise, the sort of main values. So the first one, of course, is generating plans in your style. So it's your wall width, your door width, your furniture. Everything is going to look very, very familiar to you when you're generating because the input, the data set is really the foundation of the output. So just as with any sort of AI model, a good input results in a good output. So this is why we put so much emphasis on building up a really good foundational data set for you guys to work with. You always can edit everything that Finch generates. So we believe that this is really crucial, that the sort of ultimate final say is still in the hands of the architect. And you can always tweak things. You can always, switch out the furniture, really customize it and make it yours. But of course, the idea is that the data set is good enough that you don't have to if you don't want to do that. By way of creating a data set, what we are also essentially doing is creating a plan library that's hosted up in Finch. So this is a catalog of all of your past residential projects that you and your colleagues can access. It is private to your firm. And each of these plans has a lot of metadata attached to it. So you can go into the plan and see, where was this plan built? When was it built? What client ordered it? What was the project name? Was there any specific or special accessibility classifications attached to it? All of this data is associated with the actual plan itself. And then there also is quite a bit of constraints and regulation checking happening in this as well, which I will go through a little bit later in the demo. We also bring everything out into Rhino, Revit, and Grasshopper. We generate a full BIM model with our Revit add-in. So essentially with just a couple of clicks, you're getting custom families, model groups, area plans. Everything's coming in quite structured. You don't need to spend a lot of time redrawing things or work with model management that much. Side note, we also just have released today actually a tutorial on how to connect to ArchiCAD, exporting there through Grasshopper. So you guys can find me on LinkedIn and take a look at the tutorial there if you're interested in taking a look at that. It's also in our docs. Here we have a case study with one of our UK firms, Shepherd Robson. So they had a feasibility study that they had previously shelved, but then with Finch, they pulled it back out and they were able to create 30 different iterations of a building that they previously weren't able to hit the mix that the developer had ordered. So for Tom Kyle, associate partner there, what's really crucial with Finch is being able to produce multiple iterations in the same time that it used to create just one. We talk about this a lot with a lot of firms in terms of time reallocation, because at the bottom line is that Finch is going to give you more time back. And kind of what you choose to do with that time really depends on your firm's business model and how you guys want to structure your billable hours and these types of things. So in the case of Shepherd Robson, we see them putting that back into their clients and developing more options for their clients. We also see some firms working to kind of produce more and increase their output overall. So here we have one of our other firms. This firm's located in France. They were able to design 220 apartments in just 3 hours. So they had a competition. It was due the next day. And then when we sort of got their walls and mass into Finch, they were able to generate plans really quickly throughout the project. And of course, these are in French with their French furniture up to Paris codes. So this custom data set is really the foundation of being able to do those iterations very quickly. So the workflow of Finch is shown in this diagram here. So over on the left, you always start off creating your building exterior or building mass, as we call it. And this is always created in an external software. So for massing import, we currently support Rhino, Revit, Grasshopper, as well as Forma. So the architect is always creating the mass. Once you bring it into Finch, Finch works on the inside of the building. So that's the massing studio, the floor plate studio, and the unit plan studio. We kind of divide Finch up into these three sections here. Massing studio, we of course will go through all of these, but the massing studio is where you get out your programs, your key figures. Floor plate is where you can generate your cores, corridors, unit mixes. And then the unit plan studio is where you're of course using the generate plan feature to generate plans from your custom data sets, all backed up by the Finch graph rules. These first two studios, these are included in Finch Basic, and then it's this unit plan with the custom data set and graph rules, this kind of higher level of detail. That's the main sort of difference between Basic and Enterprise, along with the Teams access and things like that. Once you've worked through the building, you can bring it out into Rhino, Revit, Grasshopper. And as mentioned, this is coming in as a native Revit, Rhino, Grasshopper file, whatever software you're using. One thing we do see with clients is they're able to kind of stay in this iterative phase a bit longer. As I'll show in the demo here, you can really present Finch projects that are active to your clients and kind of get their feedback in real time. So you can delay that push out to Revit and stay in an environment that's just a bit more dynamic and allows you to iterate really quickly and make later stage changes before making that final push out to Revit. All right, typologies we support. Multifamily resi is our main one. We include hotels, student housing, elder care, master planning, kind of all within that umbrella of residential, but this is what's sort of intended for our algorithms and what's released and ready to be used today. Softwares, to reiterate, Rhino, Revit, Grasshopper, as well as Forma. All right, now I'm going to hand it over to Reuben, who's going to take us through the massing studio, as well as generating floor plates. And then I'll take it back over and we'll go through the Finch Enterprise features where we're generating plans. Then we'll go through some new features and then we'll have some Q&A at the end. All right, Reuben.
Thank you, Amelia. I'm going to jump in and share my screen here. Here we go. So we're now in Finch and we're now in our massing studio, as Amelia described. So we have these three different studios that we're going to look at today. We're going to start here in the massing studio. What we're seeing on our screen here is our volume or our mass that we've uploaded directly from our native software, and it's landed cleanly, nicely here in Finch. So far, we haven't really told Finch how we're going to work with this project. So we're not getting a huge amount of information. But the first thing that we are seeing, and the first kind of key bit of data and metrics that we can see on our screen here, is we have our GFAs, our gross floor areas already popping up, as well as our usable floor areas, things like this. So these are going to constantly update when we're in our massing studio as we begin to describe our kind of mix of residential, commercial, retail, and things like this. Over on the right of our screen, we have what we call our data drawers. So here we have our programs, space types, unique units, things like story heights. We see if we open this, it's going to come to life now because we can see that we have our ground floor at 4 meters and every floor above at 3 meters. When working in Finch, if we're not seeing the colors that we want to be seeing, it's usually a case of just needing to open the correct data drawer. Things are going to come to life. So let's start ascribing some programs to this mass. How do we do that? Well, as we can see, Finch has already separated our mass into floors. So let's go ahead and select one floor and assign a program. Let's perhaps say that we want retail on the ground floor. The moment we do this, what do we see happen? We see our rings begin to update over here on the left, and we can see a breakdown of the total GFA as our retail area. Then let's go ahead and ascribe a program of residential for the floors above. To do this, we can select one floor, hold shift, and make sure we have all of our floors selected and sign up residential. Now we see that our rings have closed and we have all of our floors being used. So we can see we have 83.3% here of a residential split, as opposed to the 16.7 in retail. If we come over here to our data drawers, we can see that we have different options that we can look at here. So we can look at NIAs, we can look at quantities, so kind of how many floors are residential, how many floors are retail, things like this. And then if we come over a bit further into our eye, we can see that we can turn on things like our sun, so we can have shadows, and we can turn on and off our custom geometry that we've brought in from our native file. What I'm going to show you here now is that whilst as I've ascribed these programs here in our massing studio, if I go ahead and open Rhino, where I originally modeled this massing, I can see that's already begin to update in the software. Just to show how quickly this sharing of information is, if we change this one to retail, it's going to update here, and we're going to see it update almost instantly back in Rhino. So now that we've ascribed some programs to these levels, we can go ahead and actually jump into one of these floor plates. When we think about Finch, we kind of start at this scale of the whole building, start ascribing the programs, and then we're going to zoom in, and we're going to zoom in a bit further. So we're kind of constantly kind of digging and diving deeper and deeper into the building as we go. One final thing I'm going to add whilst we're here in our massing studio is that if we come back to our data drawers, we can also click on our programs and we can add properties. So for example, if we know things like budget, we can say that we have $1,500 per square meter, things like this. We can click OK. And then if we change this here, we can come down to budget and we can see the total cost for our residential. So this is just illustrating that in this early stage, we can get some really interesting metrics out of Finch. Another thing to think about is the fact that if we look at our residential here, our breakdown, and we perhaps aren't happy, we're not hitting our numbers, a bit like in the case study that Amelia spoke about earlier. Well, what can we do? Well, what's really great about, I think, the workflow of Finch is that nothing's kind of ever locked. So what we can do is we can just jump straight back into our native software. Let's call it, let's say, Rhino or Revit. We can just update our conceptual mass. We can update our volume, and then we can just simply re-upload it to Finch. And we're not going to lose all this data that we're going to put in. Instead, our volume is just going to grow, and we're going to see our metrics increase. So wonderful. Now that we're happy with this, I think it's about time that we jump into one of these floor plates and start generating a custom core and a corridor. So let's go ahead and jump in. So we're now in our floor plate studio. If we ever want to get back to our massing studio, we just come up here. Very simple to jump back and forth. Let's go back in. And if we ever want to move between our floors, we now have this really handy floor plate slider. So we can slide down and navigate between our different floors right here. Great. So now we're in our floor plate. I think it's about time that we start designing our custom core, and we can then start looking at iterating some unit mixes around this corridor. So how are we going to do this? First thing is we're just going to select this area here, and we're going to come up to generate, and we're going to select unit mix and corridors. Before we do this, let's just see what other information that we have here that we can bring up. If we come up here to our grid lines, we can see that we've also brought grid lines in from Rhino. And a really crucial one when we're designing our corridors is to come up here and look at our center line. Our center line basically is us just telling Finch where we want our corridor to be placed. So we can draw this directly in Finch. We can make any edits to the center line right here. I think, like Amelia said, it's really important to always remember with Finch that when we're iterating and when we're making all these kind of design options, we as the architects, we're always in charge, so we can always adjust and get Finch to work for us, not the other way around. So if we want to edit the center line here, we just can come up and we can extend it, anything like this. So if we're happy with the location of our corridor being here in the center of our building, I'm going to go ahead and click Generate Unit Mix and Corridors. What Finch is going to do is it's going to start to come to life, and it's going to start iterating these up to 10,000 times to find the best layout of our corridors. Well, the question is, where is it getting this information from to lay out the best corridor? Well, then we're going to navigate over to the left of our window, and we're going to look at our filters and our data. And this is really the time where we, as the architects, can really kind of put in these metrics, put in this information, and tell Finch what to iterate from. So let's start at the top and work our way down. Firstly, we have our number of stairwells. We have a slider here. So we can tell Finch to try and find a great solution between 2 to 6 stairwells. As we move down, we have our egress distances. Now, these are really crucial. Don't have to tell you as architects this, but these are basically our fire escapes. And so these are Finch trying to work out access to multiple fire escapes or single fire escapes. What we can see here is we have our distance to a single being 18 meters. If we change this to 20, for example, we're going to see that Finch begins iterating again. Anytime we basically make any adjustment here to our filters, Finch is going to start iterating, so you don't have to start this process over. And then what we can if we come down here to our data draws again, we can see in our egress distances that we have green says that we have access from any of our apartments is within this 20 meters. So we're really hitting our numbers here. So this is great. It's iterating again, and now you can see that where it's come up as red, it means that we haven't got this less than 30 meters to 2 exits. So this is not an option that we're going to be happy with. Every single dot that we see along here, every single node is a possible access to an apartment. So what I'm going to do is I'm just going to adjust our stairwells to 4 and let it iterate again as we keep going down. Next in our information, we have our weights and we have our sliders. If we slide them all the way to the left with any of these different metrics, then we're telling Finch basically to not prioritize that information. And then the more we pull it to the right, the more we're telling Finch to really prioritize that. So for example, here I have my place stairwells in corners. As we can see, Finch is placing all of the stairwells, all of our cores in the corners. If we slide this all the way to the left, we can see that won't be as important for Finch. But if you're anything like me and you're an architect that likes symmetry, I'm going to pull that all the way back up again. And then we can choose things like even distribution of stairwells. So perhaps if we haven't got a U-shaped building, if we just have a long building, and we want our cores at regular intervals, then we pull this all the way up, and it's going to try and create an even distribution. If we keep going down further to our dimensions, here we kind of have like our hard data. So these are things that Finch is it's not going to be flexible about. It's going to make our cores like exactly the size we want. So we can, for example, make our core width 6 meters, and it's going to begin again. Now, I think I'm pretty happy with this layout, but the final thing that I'm going to tell you about is our stairwell attractors. Our stairwell attractors, if we turn these off and we turn them on here, we're going to instead be asking Finch to try and place the corridors along these facades instead of the interior. So our stairwell attractors are they're really great for if you know the context of this building better than anyone. So if you know that you want all of the stairwells and cores kind of facing the courtyard of your building, like I think we do in this instance, then what we're going to do is we're going to turn our stairwell attractors on here. Wonderful. We'll let it iterate for a little bit. We can pause at any time once we're happy. So let's go ahead and pause. And what I'm going to do is, instead of generating units here, I'm going to apply plan. So I just bring in our circulation spaces here. It's synchronizing and now bringing it in. If we come down to programs, we can now see that we have a split of residential spaces and circulation spaces. And now what I'm going to do, just to show you, kind of reiterate this point that we're really trying to land, is that Finch is you're in charge. So if you want to perhaps move your wall here, so your cores are aligning with your grid lines, it's as simple as just selecting your walls and moving them up. Great. Now, the reason I've just brought in our core and our circulation here is also to illustrate that when we're in our native software right at the beginning, when we're making our massing, we can also actually draw our cores at that stage. For example, if we're working with retrofit or working with an existing building and we already know where the core is, then we can draw it at that stage, bring that into Finch, and then run our unit mix around that existing core. And that would essentially look the same as what we have on our screen here. So now that we have this, I think it's time to start actually laying out some units around these apartments. So first thing I'm going to do, because we have a symmetrical building here, I'm actually going to come and select my wall feature and come to our midpoint and just draw some walls down the middle here to separate our building into these two sides. I've done this because basically this is a little trick to tell Finch that when we select these both sides, we're going to ask it to mirror. So we're going to have identical kind of unit layouts on both sides. This is really good because then when we go ahead and use our smart copy and paste tool, we can copy our apartments, our unit layouts from one side over to the other. So now that we've selected our residential area, I'm going to go ahead and select a unit mix around existing corridor. And the same thing is really going to happen. Finch is going to start iterating based on this data that we have available on the left. So let's take a moment to jump over to that data and see what Finch is iterating from. So the first thing that we can see here is we have our unit mix. So these are kind of the really key figures, if we have our developer, if we have our client saying that they want this certain mix of apartments, of units, this is where we can specify this here. So let's say we want a third of these. Let's perhaps say we want some smaller apartments as well. We can go ahead and adjust this here. And now again, we come down to our unit weights and we look at these sliders, which is all about kind of prioritizing. So if it's really crucial to us, say like we have some kind of we have some fixed apartments in our studio that are 45 square meters that we know work really well. We want Finch to try and kind of pull out as many apartments that are exactly that size. Then we can turn our size metric all the way up and it's going to try and find apartments that are exactly 45 square meters. And then if we scroll down and look at the different things, for example, this is really key. We have our grid lines here. So we've brought our grid lines in from Rhino and we're going to ask Finch to try and land the wall as close as possible to the grid lines. A really nice other feature that we have here, as we keep going down, is we have our dual aspect size. So for example, in this project, we're wanting a third of our projects to be 95 square meters. So let's say that every apartment above 90 square meters, we want it to have dual aspects. We want it to have two facades that will let in daylight. So we can stipulate that here. And then we can do things like we can specify our unit width. And I think this is really crucial because for example, if we have a very deep building and we want our unit width to be, let's say, 4 meters, we can just change that here. And Finch is going to start iterating again. At the same time that this is all happening and you're updating your key metrics and data here, we can come over to our data drawers again and see our separation of space types. So these are things like our circulation space. We can see the space type is corridor. At Finch, we kind of work with programs, which is over the kind of the general scale, and then we have space types when we're zooming in. And our space types are basically really crucial for telling our algorithms and telling the AI where, for example, we should have things like access, where we should have daylight, things like that. And then if we come down to our unique units, we can kind of see the split of our units here. We can see how many, we have We have 8 at 46 square meters, so it's going to be really great for kind of using the same plan over and over again. So once we're happy with this, which I think we are, let's go ahead and pause and let's apply our plan. So look at that. In a matter of minutes, we've been able to kind of run thousands of iterations to find a unit mix and a unit layout that we're happy with. We have it laid out nicely here on just this floor plate, but just so that we can get all of our good, kind of get some really good information out here, we can actually go ahead and select our floor here, copy it below, and it's going to synchronize here. And look at this, we already have kind of all of our unique apartments laid out over this project. If we come back into Rhino, we can see that we actually even have all these apartments laid out already. So we have this really nice synchronization of data back and forth and simultaneous, like Amelia said. At this stage, we can also jump back into Revit and export these as native BIM files. So I think that's everything from me. I think I'm going to pass back over to Amelia, who's gonna keep going.
Great. Thanks, Reuben. All right, so I'll go ahead and share my screen here. So what Reuben has shown so far is essentially what sort of the main features of Finch Basic. We do have some plan features on Finch Basic. I will show you those here in a second. Essentially, it's kind of like a smart copy paste. But what I'm about to show you here with a large data set generating plans, this is an enterprise feature primarily. So I think you guys should all be able to see my data set here. Looks good. So here we have a plan library, as we call it. And this is for Acme Architects, a demo firm. So say that I'm an architect at this firm. I can go into my plan library and look at what my colleagues have made. We have 190 plans in the data set. That's a good amount. I can start to sort of click through these and see, how do they compare to each other? We have some diagrams here that show us, our area versus edge count, space count, how open is the plan, these types of things. So we just get a good overview of, this plan compared to everything else we have. I also can plot some other sort of diagrams, so I could show my area spread. In this case, this is a really great data set where we have plans pretty consistently across, the range from 25 square meters up to 90. So I'm going to be able to generate a lot of plans in those size ranges. I also could take a look at my edge count versus my area. So here I see these are all of my 4-edged or rectangular plans and kind of the area distribution there. And then we get up to, of course, 6-edged L shapes, we have less. And then, of course, as we get to more complex ones, we do have less and less. One thing when we build the data set, Finch can complexify plans essentially when generating. So we build a very rectilinear, simple data set that then can be transformed into curved plans or other types when it's generated. We typically don't add curved plans into the data set to start with. On the left side here, I can just filter through my data set. So look, what are hotel rooms, what are apartments, student housing. So I can just filter for those. I can see the tags associated with plans. So if I want to find like all the plans from a specific project or a specific client, I can of course find those, maybe all of the ADA compliant plans. These are always sort of available there. But if we go ahead and just jump into the apartment here. So here we have the plan editor, as it's called, and you can see the graph overlay here. So this is that kind of collection of nodes where we basically place these nodes in each space and then map the relationships between them. Right now, we don't have any errors showing. Everything is in blue, so it's kind of good to go. But if I do make an edit, even in this studio where we're not even in a project yet, and I do something like that, Finch understands that there's a clear space around this bed and that it needs to be respected. And in this case, we have a collision with this closet. So Finch is throwing an error already here, just telling us, hey, there's an object collision here. Of course, when we go into the actual context of a project, there we can set up more rules for areas and things like that. And then we can, of course, produce even more errors. But already here in the plan library, we do have kind of some initial checks to make sure that the plans are going to be kind of heading in the right direction. It's essentially a spell check is how I often describe it. Kind of building on that, we also can preview in this studio how we might adapt a plan. So, what would happen if we wanted to take this plan and stretch it to make it a little bit bigger and kind of readapt it and reuse it in a different context. So here I can kind of preview that happening. And, if I go very extreme, we're not going to generate a plan to be this much larger than its original size. But this really does show me kind of the proportions and how this plan will be affected when regenerating because we see that things are really not moving proportionally. And this is really intentional. So when we set up the data set, we will use your local regulations to kind of guide the placement of constraints. So here we see in this plan, the bathroom is locked. So it's a fixed module. It will never change dimension, which is, repeatability. This is what we want. Same with the corridor. We don't want that to get any smaller and we don't need it to get bigger. That's just going to be wasting space. And then these bedrooms, they're at their minimum width. So if they are to, have to adapt, we want them to only get bigger, never get smaller. And then here on the living spaces, this is where we kind of leave it a bit more flexible because those are usually the spaces where you can afford to have those kind of transformations. We also set up tagging systems for each plan. So essentially, when I was generating with this plan, I could search and say that, okay, here I want to generate a New York City regulation plan that's ADA compliant, type A, built after 2023, ordered, by this client originally. And I can kind of get all of these plans that have those attributes. So basically, the more data that we put into the data set, the more control you have on the sort of project side to filter and find specific plans that are going to actually fulfill all of the requirements of the specific scenario you're generating for. So this is the data set. So now we're going to jump over into a project and actually generate with the data set. So I have a project here. This is similar to what Reuben was showing you before. I've, generated the core, generated the unit mix. Now I'm at the stage where I'm ready to start working with some apartments. So I'm just going to go ahead and click generate here. And what we're going to start seeing is Acme Architects, which is my firm, is going to start supplying some plans up top. And I'll kind of let them filter in here. I can already start to play around with them while it's still generating. So here I can just start to preview them, see how they compare. In our demo data set, we have a lot of different styles. So this is a Swedish standard plan. Here we have a French standard plan. So you can really see just how different the plans can look simply based on their origin. And of course, when we build a custom data set, it's going to be with your own plan. So it will look very, very familiar to you. Here we have much thinner walls in the French plan versus the Swedish plan. And of course, much more accessibility circles and these types of things. You also will always get Finch generated results. So these are sort of from all over the world, and everyone in Finch can access these ones on the enterprise tier. And you'll notice that these ones don't have furniture. So if you do want to work with the Finch plans, you'll always get a lot of them. But then this does require a bit of, refinement after the fact, probably dropping your own furniture, maybe updating the wall width. So this is kind of just up to you and your workflow. The fastest plans and the fastest workflow is always going to be using your own plans that are pretty much just assign and go, essentially. So we see that we have generated 1,000 plans. So that's a lot to sort through. So what I like to do is use some filters just to, sift through all of these 1,000 plans and find ones that are going to probably be a bit more relevant. First thing I'll look at is my graph. So I've set up a little graph system for this project saying my double beds need to be 9 square meters, single bed 7, bath 6, etc. And worth noting that, of course, we also support Imperial. This is just set on a project by project basis. But up top, I see that I don't have any errors. All these plans look great. As I start to go down in my results, down to an 81% plan, here we do see that we have something highlighted here in red. If we hover over that, we see that essentially this bathroom is just a little bit too small. So we're breaking our 6-meter bath rule. And the reason that we still show this, even though it's producing an error, is because this is really crucial that the architect is still in the driver's seat because, maybe in 25% of the units in this building, it would be okay to have a little bit of a smaller bathroom. But you, of course, know that the best. So we just want you to be informed and make these decisions knowing that you're kind of breaking a rule and have it be a conscious choice rather than being surprised later on. Of course, if you don't want to have to do any editing, you can always just filter these out. And now, all the plans that have errors are hidden. And I don't need to worry about anything like that. But the gist of it is that we want to provide you the option to choose, essentially. But now these plans are all looking great. So pretty much any one of these, it's kind of just more about my aesthetic preferences at this point. I can, of course, use my tags to find, maybe ADA compliant, wheelchair accessible, dual aspect, single aspect, these types of things. We can also filter by city, country, any type of region here. We could say we want, a 1 bed, 1 bath. Yeah, these types of things. We can also sort for residential student housing, if we have sort of sub data sets. I do have some scores here. So on this one, I see that the adaptivity, the total score is 98%. So over on the right here, I can take a look at why Finch thinks that. And essentially, it's a combination of three metrics. Adaptivity, this is how much we have to adapt the plan from its original size. And because what you've built before is always going to be, the closest to your regulations, Finch doesn't want to, take a plan and regenerate it into an apartment that's twice its original size, because then we're losing a lot of the local context, we're losing the spatial hierarchy. So it's always going to, score a plan poorly if it has to be transformed dramatically. It's always good to be close to the original. So here in this case, we have a really great original score. We see that the bed, bath, storage, these are all their original dimensions. And then we see that it's this living room and the kitchen that has taken the bit of flex, which is this is a great scenario for us. And of course, this is controlled by the constraints we set up. Compliance, this is checking for graph rules. So we've already filtered those out. So, everyone is 100% here. And then daylight, we're basically looking at spaces that need daylight, have access to the facade. And of course, this is set in the data set as well. Once we are happy with a plan here, let's say that we like this one, assign it out. And now essentially that plan is baked. So it's editable. I can go in here and I can add, any type of, furniture. I have my firm's little library here. If I am doing any sort of editing, I always do turn on my graphs because that's essentially my spell check. So then that can be a good way to just ensure that I'm not going to produce any errors. Like in this case, I see a slight collision. I could choose to ignore this, but also, it will take just 2 seconds to move it around and then we're good to go. So it's just nice to have that graph there in the background, checking on what you're editing after you've generated. We like this plan. I'll take a look at my floor plate, and we've generated a lot of identical units here, which is great. That means we can reuse this plan. So I'm just going to hit Control C. Then I'm going to hit Control V. And then we've dropped that plan in. And you'll notice that the plans have been auto-rotated. Finch is aware of facade, entrance points, these types of things. So it makes this auto-rotation happen. And if we jump into the plan is used in 10 units. We move something around, that's going to commit to all instances. We can, of course, control our mirror as well. We maybe want the bedrooms to sort of line up here. It's just a quick transformation. Excuse me. And these, of course, are still linked, but we can also explode them out if we don't want them to be linked when we push them into Revit, because these will come in as a model group by default, but we can always, explode them out if we want like a left and a right version. Once we're happy with that, we, of course, continue generating throughout the floor, but we can also copy in 3D, just as Reuben was showing prior. And we're going to create even more model groups. So it's going to be quite a big linked group here. Let's jump in and see what we have. So 120 units we're managing all at once. And of course, the editing that's happening here is local. So everything is really quick. But then when we jump out, then it's going to sort of process those changes and commit to all 120 instances. All right. So that's sort of the way to work with Generate Plan. Once you sort of have worked through your project, then you can always bring it out into Rhino, Revit, Grasshopper. So I'll quickly go through some export options. So we'll just jump over to a completed project so we have a bit more interesting plans to look at. And here I have a high-rise. Looks good. A lot of spaces in it, a lot of data. So I want to bring this one out into Rhino. So let me just open up Rhino. Here I have that live sync. And essentially what I'm going to do to export this and kind of break this live sync and have something in Rhino that I can actually edit is import 2D and then import 3D. And when I do that, I'm going to get these extra 2 layers. So what I'll do is just turn off my live layer, turn on my 2D layer, go into my top view, and we'll take a look at what we get here. So you can see that we are getting 2D plans, one for each floor, building A, story 4 of 21. And if we expand this, we can turn on and off different types. So, we have blocks for furniture. We have the programmatic data as well as the spatial data. So I can turn that off and see the actual spaces. So you can get this data down here. We also bring in a 3D structure as well. Let me just turn that on. There we have it. So here we have this 3D structure. And of course, the actual apartments are kind of as a group. And then the story walls are a different group. And of course, everything we bring into Grasshopper as well. We have a few Grasshopper tutorials on our doc, so feel free to have a look at that. But you could, of course, bring all of this plus a lot more data into Grasshopper. We have connections to Ladybug, things like that. And that's also where you connect to ArchiCAD. If we jump over into Revit, take a look here. Here we have another high-rise. So this is a New York high-rise. We have the key figures. This has been fully generated. So we have a really nice interactive diagram. We see our total resi office. We see all of the different rooms. We can see the the quantities, these types of things. And so I can present to my developer in here or my client directly in here. But once I'm ready to bring it out into Revit, just to show the type of data we get, here we have this plan. And into Revit, we are bringing in actual model groups. We bring in a full 3D model. So we have this model group with this naming structure inherited from the data set itself. And then within that model group, we have specific families for, Finch unit wall, 120 mil. And this width will be what the widths are that we set in your data set. So you'll have different widths for bathrooms, bedrooms, these types of things. Furniture is coming in 2D with your own firm's naming structure. So once you're at this point, it's kind of a matter of selecting all instances of this, wall and then converting it to your own templates to sort of continue from there. We, of course, have the area plans. You can create custom schedules. We bring in all of the rooms and everything. So you have a lot of data there that's ready to be kind of fed into your typical workflows once you're down in Revit. All right. I think the last thing I will show before handing it back over to Reuben for him to show generating in Revit is working with our master plans. So this is a new feature that we have recently added into Finch. And this allows you to work with a lot of buildings all at once, kind of streaming into one single variant that you can view, but having, different essentially variants for each building within it. So if we jump over out into the project, in this project, I have 22 variants. So that's a lot. I've been testing a lot. I've been working around, with different copies of different buildings, maybe making, a few different proposals. So I might want to be able to present all of these buildings kind of together, especially if I'm working on a single building in different on one site. So if I scroll down, I have my master plan bundle. And if I click on that, I can see that I have quite a few buildings popped in here and I get a lot of information about them. So I see my total GFA for the whole site. I can take a look at, my embodied carbon. I can take a look at the revenue. So I get a lot of information here. I also have my unit mix targets for the whole project, and I can see the percentages as well as the counts, if I'm hitting those or not, and also the unique units across the entire master plan. So here I can see that I actually only have 15 unique units in this whole master plan, which is really great. That means I can use a lot of repetition, and it saves me an incredible amount of time here. Over on the variants bundle here, I can see that I have every variant that I have in my project is accessible here. So I can kind of just toggle these on and off and choose which ones are streaming into this. And of course, when it is toggled on, that's when the data actually is going into those calculations. So if you have a few different options too, you can, toggle, okay, this is master plan option A, and it has these numbers. And then if we toggle the other ones, we can see different combinations and what happens if we switch out buildings. So this can give us a good idea of, how to puzzle together these buildings in the master plan. And of course, if I just click on one of these, I can open it up. And then we're going to jump into the actual variant here, which I think in this one, I put 2 buildings. I mean, you can have a few, you can have one, it's kind of up to you. But just to break it down a bit. And then within that, I can see the spaces and these types of things. All right. I think with that, I'm going to hand it back over to Reuben.
Thanks, Amelia. Let me share my screen again. So as Amelia said, I'm just going to demonstrate a new feature that we have that we're really excited about here at Finch. And this is the option to actually generate these unit plans directly in Revit. So this means that, if you have members of your team that are really comfortable working, just want to kind of stay in their native software of Revit, then now they're able to look at unit plans and layouts directly here. So how do we do this? Well, what I was working on with the unit kind of layout in my last little tutorial, I've now imported this BIM, this software into Revit, and it's come in with all the correct floors, area floors and things like this. Then simply what we're going to do is we're going to come over to our Finch plugin that we have, and we're going to go ahead and click on Generate Plan. It's then going to ask us just to select any of these units. So let's start with this one here. And then the last thing it's going to ask you to do is just choose the wall that you want to have access to the apartment. Obviously, if we're looking at this apartment, we could choose these 2 walls, but for here, we're going to just select this one here, go ahead and click Finish. And it's going to bring up this window. And it's going to start generating plans. Now, I think the really exciting thing about this feature is that so now, as you can see, we have like our organization plans. So this is for our Acme architects, our in-house architecture studio. We're starting to see these come up with all the furniture and all the layouts that Amelia just explained, kind of how we get to these layouts in her last bit of the tutorial. So let's go ahead, and we also, we can see the numbers here that was explained, kind of what percentage, how suitable they are for this layout. I just want to demonstrate that if we go ahead and just select on one of these, what it's going to do is it's going to bring it here into Revit. If we go ahead and select done, now you might think this is just 2D, but actually what this has done is it's brought it directly in as a model group. So we can go ahead to our section box, and we can actually see these walls in 3D. So we have our 3D doors, 3D walls, kind of everything ready for you to like start working in Revit. So this is a way of just like really speeding up this early stage process and actually using this like exciting AI plan generation directly here in Revit. So that was super quick, but I think that's all from me. I believe now, Amelia, we're going to try and go through and answer some of the questions that have been asked.
Yep, I'll go ahead and share my screen and take a look here. All right, so just to sort of do some review, sort of what's included in Finch Enterprise and Finch Basic. So, of course, the generative algorithms for the floor plate are included in Finch Basic. But when it comes to the plans, there's definitely some key differences. Of course, everyone has access to the adaptive plan. This is smart copy paste. Generating in Revit is currently available to both Enterprise and Basic, but in sort of different levels. So if you're a basic user, you can currently generate using the Finch dataset. You don't have access to a private dataset. And of course, generating in Revit is not supported with graph rules, curve shapes, more complexity. So it is kind of a limited version of that. We are currently making it available for basic users. It might not stay that way, but right now, feel free to go in and test it out and see what you guys think. And of course, generating in Finch is available currently on the enterprise tier. So before we jump into Q&A, I have a quick poll that it would be great if you guys could fill out for us, just to give us an idea of sort of, where you're sort of coming from, what types of projects you guys are working with, these sort of things. So I will go ahead and launch this. And if you guys can just fill it out, it's just a few quick questions. It would be great. And also, if you want us to reach out to you about Finch Enterprise, just let us know as well. All right. Think you should be seeing the poll. Let me know if not. Yep, looks good. All right. But just to reiterate, so Finch Basic is available already today. It's €49 a month. Feel free to go ahead and take advantage of the 14-day trial there. That's where you can test out generating in Revit as well. And Finch Enterprise is available at the €12,000 per year price. And we'll send out some information after this about how to get in contact with us if you're interested in Finch Enterprise for your firm. With that, I think we can jump into the Finch Q&A.
Let's do it. We have quite a lot of questions here. We're not going to be able to get through them all, so please don't be upset if I don't choose your question. Like Amelia said, we also have the Finch docs, which is a great place, a great resource for you to find answers to kind of lots of these questions. So I'm going to go ahead and ask some of these questions. So first of all, is there a Grasshopper plugin for Finch?
Yeah, absolutely. So when you install the Rhino plugin via the package manager, you also automatically install the Grasshopper plugin, and we have quite a few tutorials in our docs about how to use that. So feel free to have a look there.
Great. Is there any viable use case for high-end bespoke architecture, or is it meant mostly for architecture competitions and large-scale projects?
Yeah, I mean, you can use Finch in any type of project. Finch actually really thrives with sort of complexity. So if you have more unique sort of unit types, this is definitely something that we can support, and especially with the floor plate algorithm, absolutely. One of our clients is working sort of on a bespoke Alpine project as well. So this is something that we do support.
Wonderful. And then the one below, we should have covered this, but are we able to change the unit of measurement using the basic version?
Yeah, so that's available on both tiers. It's something that you change in the project. So you can have some projects in metric, some in imperial, just based on where it's located.
Then we have a question here about if it's possible to automatically import kind of maximum egress distances and kind of any other restrictions from local standards.
So currently, with everything that has to do inside of the project, that's like setting up graph rules and egress distance and playing with the algorithms, all of that is input by the architect on a project by project basis. But we are talking a bit about sort of custom profiles. I think this is something that will come in the future. But right now it is set up by the architect per project.
Let me a look. We have a question here about how about ArchiCAD. I think we covered it, but
yeah, feel free to have a look at the tutorial. It's also up in our docs. So with the Grasshopper ArchiCAD connection, you can stream your projects directly over there.
Do we have control of vertical heights, or is that just a standard?
Yeah, so you can always edit the floor height. So the default that it gets uploaded as is 3 meters, but then you can just go and select all, add a new height, select specific ones. So that's set by you.
Wonderful. I think we've got a really interesting one here. How well does Finch work when it's not 90-degree corners?
Yeah, we definitely support curved. I don't think we have time today to. Sometimes I will show that in these webinars, but we do support curves. We support oblique angles. This is no problem. As I mentioned before, Finch is good at complexifying plans. So we have a rectangular plan of the data set, and that can be translated into a curved edge, an oblique angle. This is no issue. And with the floor plate algorithms as well, we have a lot of different parameters for working with curved buildings versus rectilinear because those are really different puzzles to solve essentially. But you can find some more info about that in the docs.
I think we only showed in our tutorial kind of circulation spaces that ran perpendicular to facades. But if we have kind of skewed facades, then we're also able to generate units which don't have these kind of 90-degree angles as well. What happens to any custom floor plans that we add to Finch?
So they're completely private to you. So if you're on the basic tier, you have your own private library. No one else can access it. If you're on the enterprise tier, your plans are private to your firm. You also do have your own personal one as well. But the firm plans, you guys own them. All the data you create, you still own. So it's pretty standard in terms of copyright and privacy policies there.
Brilliant. And can we stipulate minimum floor areas for various rooms?
Yeah, so that's something you can add in the project with the graph rules, and then that applies to all variants within the project. So if you have, a site in New York, then you input those New York regulations, and every different proposal will, of course, follow those.
Great. Can we add inset balconies to our apartments to the parameters?
Absolutely. So that we support this. We can just put them in the apartments as almost kind of rooms, essentially. And then we have a daylight permeable wall. So Finch still understands that, even though if there's a balcony blocking the bedroom still has daylight access and these types of things. So that's a supported use case for sure.
Awesome. And how well does Finch work with an existing floor plan? That's a good question.
Yeah. So we can kind of jump into Finch at any stage. So we didn't go through this today either, but you can upload walls from Revit as well. So if you've already solved the floor plate, you can just send it up to Finch and generate the apartments. If you're doing maybe like an adaptive reuse where you have a fixed core and you can only knock down some walls, you can send those walls up and kind of generate with those constraints. So you can really jump into Finch at any stage of the project. It doesn't have to be a new build in concept stage. It can be a pre-existing project pretty late as well.
Awesome. We have a question here about if we can set window locations or facade constraints that Finch would respect when it's generating plans.
So we don't have active support for window apertures. When we're looking at daylight, it's looking at daylight access. What we do use to kind of, we see firms using this method is using the grid lines when generating apartments to ensure that kind of that window spacing is respected. So if you have, like a 6-meter facade system, Finch can respect that when generating.
Wonderful. Question here, how do you prepare your own data set to train Finch on our firm style? Do you have to tag the plans yourself, or is there an algorithm that understands the typology by itself?
So the building of the data set is a service that our in-house architects do that's included in the cost of the enterprise tier. Currently, this process is pretty manual. This is why we only sign around 3 firms per month max, and we also need to plan in data set build. So usually we have a lead time too after signing before we have the data set sort of ready, max 1 month. Because we basically will just take your plans in any format. You guys don't need to prep them too much, but we will have an Excel sheet you fill out with some typical naming structures as well as some typical tags. And then we kind of extract those plans from what you have pretty much lying around. The idea is not that you guys have to spend a bunch of time preparing a data set. This is something that we're doing on our end.
Great. We've got a really good question here about if we can continue service shafts vertically from floor to floor if we're changing the unit mix.
Yeah, so if you add it in sort of as you can draw in a shaft and then just copy it the same as you would an elevator shaft or this type of thing and certainly generate around it. You can also include shafts in the apartments and Finch will generate with those shafts. This is some firms do this, some firms don't. It just depends on how specific you guys are in your early stages, but absolutely.
Wonderful. So many good questions, so hard to choose. Let's have a look. What else have we got here? When stretching our units, this is actually a good question. Is there a way of like seeing those visual dimensions whilst we're stretching? So we see kind of dimensions updating in real time.
If stretching in the plan editor, yeah, you can
Yeah.
absolutely turn on your dimensions and have those update as you stretch for sure. So the dimensions are always just a visual toggle on or off if you want them to show.
Great. And then maybe a final one here. Maybe we've got a bit time for maybe two more. How are disabled accessible regulations considered in the plan generation?
Yeah, the typical way we work with that is with accessibility circles. We of course have clear space. We can input, wheelchair turning circles and these types of things, and then Finch is respecting that with the graph rules. So typically, is what we would do is we would add a plan that has these attributes and then tag it as wheelchair accessible or ADA or kind of whatever you want it to be known as. And then when you're generating and you say, okay, here I need an accessible unit, then you would filter for the tag that your firm is using to basically denote that.
Okay.
Huh? Wonderful. All right. I think that's it. We will go through the Q&A and perhaps send out an email with the answers to these. Feel free to reach out to us as well. You can connect with us on LinkedIn and message us there. You can also reach out to us via the Finch chat if you guys want to get into Finch Basic and give it a spin. But otherwise, we'll probably run another webinar in about a month or so. I hope you guys are having a great summer, and we'll be in touch. Stay tuned for our email with some next steps as well as the recording. All right. Thanks, everyone.
Wonderful.
Have a good
Thank
rest
you,
of your day.
everybody.
Bye.
Bye-bye.